Here we have our final example, and you are given your demand and supply function. Note that in this example, the functions are linear, but it's for illustrative purposes. For your applications in the exam, you won't get linear functions. And you will be expected to use integral calculus. If the question specifies so, you must use integral calculus. So it says calculate the consumer surplus and producer surplus using the integration method, and it also says hence determine the total welfare gains to society. So it just means calculate total surplus. Now, first off, if you just use half base times height because you've got linear functions and you can very easily calculate the areas of these triangles, you would get your consumer and producer surplus very easily, right? Here you've got for your demand function, you can see that the vertical intercept is going to be 50. For your supply function, you can see that your vertical intercept, okay, although it's not lined up, it should be 10. And in terms of the equilibrium price and quantity, you would obtain that by equating your demand and supply functions, and you can determine your equilibrium quantity, it is 10, and equilibrium price, it is 30. So to calculate the area of your consumer and producer surplus, it's fairly straightforward if you just use half base times height to calculate the area of a triangle. However, this is not what you were asked. You were asked to calculate the total welfare gains and first calculate your consumer and producer surplus by using definite integrals. So you must demonstrate that you know how to use the method. So this is just illustrating what the answer should be. Here you would get 100 for consumer surplus and your producer surplus similarly half base times height, half times 30 minus 10 times this distance, which is also 10. You would also get producer surplus is equal to 100. So therefore your total surplus is the sum of those two. It is 200. But this is very straightforward. And you would not get a problem of this nature in the exam. So let's see how you would solve for it using definite integrals. So first take your demand function and integrate that, and between your lower and upper limit. So it's said at equilibrium, so therefore you would need to determine what the quantity is at equilibrium. And in order to do that, you first needed to determine your equilibrium price and quantity, and the equilibrium quantity was 10. So that is your upper limit, and your lower limit is 0. In your applications, it will always be 0. Now, we first integrate our demand function. So therefore, this is simply going to be 50q, and this is going to be q squared minus q squared, because here you've got minus 2q, so q is raised to the power of 1. So therefore, n plus 1 is 1 plus 1. Q is raised to the power of 2 now, and then I've got 1 over 2 times this constant 2, which is going to give me minus 2 over 2, which is just going to be minus 1. So therefore, I've integrated this function and I've gotten 50q minus q squared. Now I need to evaluate at my limits. So you first evaluate at the upper limit, and the upper limit is 10, and therefore you would get an answer of 400. Of course, if you evaluate at the lower limit, if you substitute 0 in for the q's, you just get your 400 minus 0, so hence that area is just 400. But remember, for your consumer surplus, it has now calculated that entire area below the demand curve between the limits of 0 and 10. However, you only want the area above the equilibrium price. So therefore, we have to say 400 minus the product of P times Q, and P was 30, if you remember the equilibrium price, and the equilibrium quantity was 10. So therefore 400 minus 300, 30 times 10 would give you 300, gives you a consumer surplus of 100. Again, for the supply, the same story. So therefore you take your supply function and you first need to integrate that, which is this step over here. We first integrate the 10, and you can see we will integrate the next function or term, which was 2q, and you're going to get 10q plus q squared. remember, if you integrate a constant k, it's simply going to be 10q. And if you integrate that, I've got an exponent of 1, n is 1, so 1 plus 1 is 2, so it's simply q squared. And therefore, I'm going to have 1 over n plus 1, which is 1 over 2 times 2 gives me 2 over 2, but it's positive, so therefore this is just 2 over 2 is just positive 1. So I've got 10q plus q squared, and I now need to evaluate it at my lower and upper limit. So if I evaluate this at the upper limit, I'm going to get 10 times 10 plus, so that is 100 plus 100. That gives me 200. However, remember, for the producer surplus, this is the area below the supply curve between the limits of 0 and 10. However, you want the producer surplus, which lies above the supply curve but below the equilibrium price. So therefore, I need to work out that shape, which was price times quantity. Price was 30 and quantity was 10. That gives you 300 minus 200, which is the area below the supply curve. And what you're left with is the producer's surplus, that area above the supply curve but below the equilibrium price. So into your total surplus, we'll just be adding your consumer surplus and your producer surplus together, and that will give you the total welfare gains. Now, there are two more examples. Here, you are given the answers, but you need to solve and demonstrate that you do arrive at these answers. And then here, you are also given to a supply and demand function, and you need to determine the equilibrium price and quantity, the consumer, producer, and total surplus, and integration must be used to derive these answers. So, yes, I've said I don't know. Of course, I have the answers. You first need to determine it and then demonstrate your calculations, and I will provide the answers thereafter. So please work through these two examples, and in preparation for your final exam, which I think is on the 30th of October. So work through as many examples, especially in the latter portion of the work, because your exam is a combination of both structured questions and MCQs. All work will be examined, but if you think about it, the latter work you haven't really been examined on, and that is where you dealt with integral calculus and the latter part of matrices. So work through as many examples as possible. Check your answers with me, and that will be good preparation for the exam. And then also work through your past papers, your past tutorials, your past module tests as practice for the earlier work that you did, because all the work will be examined in the upcoming exam. And that concludes the final topic for ECO235.